Hi there. Today we're going to talk about site measuring. Site measuring is an important set of techniques for ensuring the placement and relative proportions of elements in your drawing. We'll start by discussing the most basic and intuitive techniques of site measuring, and that is comparison. So comparison is the most intuitive form of site measuring, and it's so intuitive that we often forget to do it. But it is simply this. We can look at our still life. Here is roughly how I want it to appear in my image. There's my picture plane. This is a pencil, by the way. And I'm going to ask myself things about the still life and the relationships between them. Which one of these things is taller, the pear or the blue cylinder? Without even doing any measuring at all, you can intuitively look at them and say, yes, the pear is definitely not as tall as the blue cylinder, which is quite tall. Now, if we asked which one is lower in the picture plane, this is another really simple comparison to do. And we could say, well, looks like the bottom of the pear definitely comes lower in the picture plane than the bottom of the cylinder. The top of the pear seems to be somewhere in the middle of the cylinder. So our pear is lower than the cylinder in general. If we ask to compare, okay, who's the lowest point in the objects of this still life? Well, the pear is pretty low, but in fact, it looks like this vertex down here is going to end up just a little bit lower than the bottom of the pear. If we in our drawing were looking at this, we would have a tendency to accidentally make this point in space and this point in space perfectly even, and there'd be no difference between the two. So comparison is just about knowing who's more to the left, who's more to the right, who's higher, who's lower, who's bigger, who's smaller. This is a great way to step back from your drawing, do some comparisons, and check on them. The next technique we'll talk about is establishing relationships between different elements on the page by using horizontal and vertical lines. And we'll call this technique reference lines. And for these, you'll need a pencil. Not necessarily for drawing, but you need any tool with a straight edge. When we use reference lines, the most basic form is to depend on our natural sense of verticals and horizontal. Assuming your inner ear works correctly, you can usually reliably get a sense of straight across horizontal lines, and you can drop a vertical with the aid of gravity if you just dangle your pencil. Once you have the ability to make horizontal and vertical lines, you can use those to observe relationships between different elements in the picture. So, for instance, earlier when we were trying to figure out who was the lowest, one of the things I did was I dropped a horizontal line across my picture plane and I pushed it up until I hit something and found that, you know what, the bottom of that pear and the bottom vertex of that red cube over there are very, very similar in their height in the drawing. All three of those corners, the corner of the red thing, the corner of that box, and the bottom of the pear, very, very similar. So that gives me something to start with when I'm setting up my drawing. I know that those three are going to have a very close relationship. If I wanted to figure out, say, the difference between the height of that pear, which is way over here, and the height of the back corner of this box, which is way on the other side of my drawing, I can still use horizontal relationships to make sure I'm getting that correct. So if I set this on top of the top of my pear, I can see that that line runs just over this corner, but fairly underneath this corner. So when I'm placing this back corner in my drawing, I know it's going to need to be higher than the top of my pear. If in my drawing it's not a good deal higher than the top of my pear, something's wrong and I need to make an adjustment. So we can use horizontal lines to test out the relative height and lowness of different things. So we can check our vertical relationships using a horizontal line. Similarly, we can figure out left to right relationships with a vertical. So if I was making this drawing and I had, say, my teapot well established, but I needed to find this pear, I needed to figure out exactly where this pear goes. Left to right, I could say, okay, if I'm looking at the still life now and make some observations, I'm going to note that the left side of the pear runs just to the right of center in the middle of that teapot. So I would go ahead and establish the left side of my pear just on that line, that vertical. And then if I needed to find the extreme right of my pear, I could say, oh, that actually lines up pretty closely with the edge of that handle. So again, if that teapot exists in my drawing, I can draw a straight line down from it, and I can say somewhere on that vertical line is going to be that side of my pear, and somewhere near the center on that vertical line is going to be the left side of my pear. This won't tell me how high and low the pear needs to end or begin, but it can give me my horizontal relationships by using that vertical line. So I'd encourage you, using horizontals and verticals, you can see relationships between different objects, even if they're far away from each other in the picture plane, and that helps ensure that the placement of things doesn't get weird and wander as you move across your drawing. The next technique we'll discuss, and this one's my favorite, is called angle of measurement. And this is one I lean on a lot in my drawings. Angle measurement is a lot like using reference lines. The difference here is that our lines are not going to be strictly vertical and horizontal, but rather they're going to respond directly to landmarks in the picture. So what I'm going to do is I'm going to use a straight edge here, and I'm going to sight with one eye closed. And if I was trying to determine what is the angle between this back corner of this box and this front corner of this box, every time I draw it, things get a little screwy. So what I can do is, sighting along this pencil, I can hold it so the pencil goes straight up and down, and I can turn the pencil in space until the pencil matches that angle. Once I've got that angle, I can say, okay, I can carry that angle straight over to my drawing, and I can draw it on the paper. Similarly, I could use it to find this angle, the one that runs through that pear, and say, okay, between this corner and this corner in my drawing, wherever those things are placed, I need to make sure that they rhyme with that angle on my pencil. Now, when you're doing this, you may be tempted to go push the end of your pencil in space like you're foreshortening. There's no need to do this at all, and in fact, it can make this technique not work. So as you're doing this, one way to think about it is that this pencil is like the minute hand on a clock, and you are just pivoting on one point in flat space. As soon as it matches, it's good to take over to your paper. So that works if you're going along the edges of things that have an angle and you want that angle to rhyme. One other place to use this, and a place I use it a lot, is between landmarks that don't necessarily touch. So if, for instance, we had this spot up here, the very tippy top of our cylinder, and we had this point in space here, we could say in the drawing, well, what is the relationship between them? They need to be just off vertical at this angle I've got here. I can go to my drawing and check and make sure that that is also happening in my drawing. If it's not, it means that somebody's too far to the left, somebody's too far to the right, maybe somebody's too high or low. Any of those mistakes are going to make this angle between this landmark and this landmark not on the correct angle. You can also do it to find things that are far away. So once again, if we had this point in space and we had this point in space and we felt good about both of those, we could use each one to find this guy. So if this guy's not in our drawing, we can find it by triangulation, and we can say, if we go from that top point to that bottom corner there, we get that angle in space. I can take that angle, I can take this in my drawing and just draw this line straight out forever. I know that this corner is going to happen somewhere along that line. Then I can take this corner and I can say, okay, between those 2 points in space, that is the angle. Very shallow, but a little bit. And I can go and find this on my drawing, make this angled line on the drawing, and where this line goes out forever and where this line goes out forever, where they cross, that's where that corner is going to live. And now I've used 2 known points to find a third unknown point. Then I can do some reference lines, I can make some comparisons, and I can confirm that that's where that guy belongs, and he is going to agree from the very beginning with these other landmarks I've got in my drawing. The last sight measuring technique we'll discuss is called unit of measure. This one is by far the most technically complex and has the most room for error. So if you are going to use this technique, I encourage you to be really careful with it and make sure you're getting every step correct while you use it. This one helps to make sure that the scale and proportions of your drawing are all set to a coherent and consistent unit of measure. So for instance, if we were setting up this drawing and we wanted to say, I'm going to start by drawing the pear. Once I've got the pear in there, everybody is going to respond to the size and shape of my pear to make sure that all my proportions stay correct. So to take a unit of measure, we can observe out on the still life, and we use a measuring stick, and we hold our arm out perfectly straight, and we close one eye and sight down that arm. I'll do my best to do it with the camera. What you do is you set the top of your stick at the top of your landmark that you're going to use for a unit of measure, slide your thumb up to the bottom, and this is where using a straight arm is really important, because if you bend your elbow, you can enlarge that unit that you just took and it won't work anymore. Okay, so we always want to set it with a straight arm so it's a consistent distance from our face. So now we've got the height of the pear. What I can do on the still life in my observations is I can ask myself, how many pears tall is the blue cylinder? And so to find that, I'll say, okay, there's my pear, calibrate it. Cool, I've got one pear, that's my unit of measure. Starting from the bottom of the cylinder, I'll say one pear to that moment, one pear to that moment. It's two pairs and maybe a third to get to the very top of that ellipse. So then in my drawing, if I've already taken the time to draw the pear and the scale is established, I can measure how many pairs or how tall the pear is in the drawing, and then I know that this guy needs to be 2 and about a third of that distance. So if I was doing a giant mural and my pear was 2 feet high, that means that this cylinder is going to be maybe 6.5 feet tall based on the size that I had drawn that pear. So my proportions match the proportions of nature. So this is a common technique to use, but it's really important to know that you have to have the pear in the drawing before you can use it as a unit of measure. Once I've got that, I can also figure out widths with that same unit. So I can say, okay, height of my pear is still the basic unit of measure. How wide is this red box corner to corner? Well, I can take that height, turn it on its side, it's still the same 2D distance, and I can say 1 to get me to that moment in space, 2 to get me to that moment in space, and it is just shy of 2, or actually really close to 2. From this corner to this corner, it is 2 pairs long. So that all seems fine. One of the challenges of this is if you were trying to measure across, say, the entire still life, that gets very tricky, because we can say, okay, there's my pear, got her. 1 pair to that moment, 2 pairs to that corner, 3 pairs to get to there-ish, 4 pairs there, 5 pairs to the edge of the pear, but I'm a little shaky, so I don't really know. 5 1/4 pairs to the end of the box. So in this, every time you repeat your unit, you're gonna wiggle a little, and there's room for some slop in your measurement. That makes your measurements less precise over time. So your unit of measure, if you've got to use it 86 times, it's not a good unit of measure. Another quick warning when you're using unit of measure is, remember, when we started using this pear, we were assuming that the pear existed in our drawing to set the scale. So if we use this pear to start establishing the size of other elements in our drawing, the height of different things, the width of different things, they're all calibrated to the pear. If some point down the road we go into our drawing and we erase that pear and redraw it or move it, and the pear changes size, all those relationships we had established are ruined. So once you've established your unit of measure, that is the law. You can establish secondary units of measure as you go, other things that are helpful once you're absolutely sure of them, but never change those initial units of measure once you've been using them. One last note about all of these techniques is they all have a place while you're both setting up your drawing and as you step back periodically to evaluate what you have against nature and try to make those things match more carefully. Always assume your drawing is a good 40% wrong at any moment, and your job is to find what's wrongest and set it closer to what you see. Some of these techniques, especially the ones that involve a lot of arm reaching and squinting and turning things, they can feel unnatural and they can feel inconvenient. My promise to you is as you train your brain in practicing these things, they do get easier and they do become more intuitive to the point that you start doing them subconsciously, and that's when you're really drawing. So I encourage you guys to practice all 4 of these techniques. Remember the name, remember what you're doing, and they should improve the accuracy of your proportions.